Today we are going to revise something of logarithmic functions. Okay, it's only a revision. I can go a little fast. Logarithmic functions. We know logarithmic function is inverse of exponential function. How is log defined? Log function defined for a positive value of a and not equal to 1. The base a is a positive value not equal to 1. Log a, log base a, we call it log base a. Log base a is a function from 0 infinity to r, open interval 0 infinity to r. Log base a of y, or we call it log y base a. Log y base a is x when y equal to a raised to x. That is the elementary definition. Log y base a is x when y equal to a raised to x. Log y base a is x when y equal to a raised to x. That is what we have to remember. Log y base a is x when y equal to a raised to x. Here a is called the base of logarithm. And see the examples. Log 25 to the base 5 is 2. Why? Because 25 is 5 raised to 2. Log y base a, and you go on chanting this again and again in your mind. Log y base a is x when y equal to a raised to x. Remember, the domain is open interval 0 infinity means, domain is open interval 0 infinity means the y value cannot be a negative number, it cannot be 0. And the base a cannot be negative, cannot be 0, and cannot be 1 also. The base a cannot be 1. So log y base a, again I repeat, log y base x when y equal to a raised to x. This should be in your mind very clearly. Log y base x when y equal to a raised to x. Log 64 base 4 is 3 because 64 is 4 raised to 3. Log 64 to the base 2 is 6 because 64 is 2 raised to 6. Is that clear? Let us see. I have taken up some examples and the proof is very simple for you. Log 125 to the base 5 is 3 because 125 is 5 raised to 3. Log 64 to the base 16 is 3 by 2. Why? How do you find? Suppose it is not given. How do you find it? We suppose that is x. We suppose that is x. So that 64 equal to 16 raised to x. And both you express with the same base. 64 is 2 raised to 6. 16 is 2 raised to 4. So 2 raised to 6 equal to 2 raised to 4 whole raised to x. Or 6 equal to 4x. Or x equal to 6 by 4 or 3 by 2. Log 243 to the base 3 is 5 because 3 raised to 5 is 243. And when it comes to log 64 to the base 32, I just explained here how it comes. Log 64 to the base 32 is x, so that 64 is 32 raised to x. 64 we write with the 2 raised to x with the base 2. 32 we write with the base 2, so 2 raised to 5. So 2 raised to 6 equal to 2 raised to 5x. Two equal quantity with the same base, powers are equal. Two equal quantity with the same base, powers 6 equal to 5x or x equal to 6 by 5. Log 25 to the base 125. Who will tell me the answer? Log 25 to the base 125. I am waiting for your response. You can use your pen and paper. Log 25 to the base 125.
2 by 3.
2 by 3. That's right. As I hinted earlier, You can easily calculate. This is because we are applying the property later. It is log 25 by log 125. You keep a base 5. Log 25 to the base 5 is 2. Log 125 to the base 5 is 3. So 2 by 3. Otherwise, you proceed like this. 25 is equal to 125 is to x. 25 is 5 raised to 2. 125 is 5 raised to 3. So 2 equal to 3x. X equal to 2 by 3. What about next? Log 1 by 64 to the base 128. Log 1 by 64 to the base 128. Who will tell me the answer?
Minus 6 by 7.
Minus 6 by 7. Absolutely right. Okay. I hope you got the points now. 1 by 64 equal to 128 raised to x. Keeping these as x. 1 by 64 is 2 raised to minus 6. And 125 it is 2 raised to 7. So 2 raised to minus 6 equal to 2 raised to 7x. So minus 6 equal to 7x or x equal to minus 6 by 7. That's correct. Okay. Let us proceed with something more. Log 64 to the base x equal to 3. So 64 equal to x raised to 3. You see, I can equate the, you can make the power equal and you go to how you get x. Log 343 to the base x equal to 3, then x equal to 7. See how we got this here? Log 64 to the base x equal to minus 6 by 5. That was actually our earlier question. But minus is there. So what do we do here? Log 64 to the base x equal to minus 6 by 5. So 64 equal to x raised to minus 6. We represent with either you can represent same power or as we are writing here, we can get x by raising the power, required power on both sides. So 2 raised to 6 equal to x raised to minus 1 by 5 raised to 6. So we have the power 6 here, power 6 here. So I equate the bases. 2 raised to 6, power is 6. 2 raised to 1 by 5 raised to 6, power is 6. You see the power is 6. So I equate the bases. What is that? 2 equal to x raised to minus 1 by 5. Are you able to read? 2 equal to x raised to minus 1 by 5. Here, how will I get x from here? I raise the power by minus 5. I raise the power both sides with minus 5. So 2 raised to minus 5 will be x raised to minus 1 by 5 into minus 5. That is x. So x equal to 2 raised to minus 5. That is 1 by 30. 2 raised to minus 5 is 1 by 30. Who will tell me now? Log 243 to the base x equal to minus 5 by 3. What is x? I'll give you 40 seconds. Starts now.
1 upon 8.
1 upon
8.
you have to go through the answer once again. Two 43 equal to x raised to minus 5 by 3. I can make the same power 5 in both. 243 is, can you say something raised to 5?
3 raised to 5.
Yes, it is 3 raised to 5. So 3 raised to 5 equal to x raised to minus 5 by 3, or 3 raised to 5 equal to x raised to minus 1 by 3 raised to 5. 3 raised to 5 equal to x raised to minus 1 by 3 raised to 5. If I write something on board, can you see the board now in the small box? 243 equal to x 3 raised to 5. So 3 raised to 5 equal to x raised to minus 1 by 3 raised to 5. Can you quit the bases? I can repeat. 3 raised to 5 is equal to x raised to minus 1 by 3 raised to 5. You should get by now.
Our answer is 1 upon 27.
1 by 27. That's right. Because 3 raised to 5 equal to x raised to minus 1 by 3 raised to 5. Raised to 5 goes. So 3 equal to x raised to minus 1 by 3. Raising the power with minus 3. You get 3 raised to minus 3 equal to x. X is 1 by 27. That's right. Log x by 5 equal to 4. What is x? It's obvious. 5 raised to 4. 625. Log x by 6 equal to 3. What is x? 6 raised to 3. That is 216. Okay. Well, some properties of log function. You don't need to worry. This may not come as a question, but you need to know this. Domain is 0 infinity open interval. The range of log function is set of real numbers. And 0 infinity to r, effectively log x base a is a bijection. Log 1 is always 0 because 1 is equal to a raised to 0. Log a to same base is always 1. Okay, log x, effectively log x base a is increasing if a is more than 1 and decreasing if a is less than 1. Of course, a must be more than 0. Okay, log y base x when y equal to a raised to x. When the base is 10, log base 10 is called the common logarithm and 10 is the common base. When a is the exponential number e, we know what is e. E is approximately 2.7, the irrational number e. When a is e, log x base e is called the natural logarithm, which is denoted by ln, log natural, ln x. But we are not using the term ln, we are only using log. And in our subject, if you don't use log, it is log base e. Okay? And the very modern rules of logarithm, what are they? Logarithm of xy is log x plus log y. Logarithm of x by y is log x minus log y. Logarithm of x raised to n is n log x. Power goes as product here. Logarithm of x raised to n is n log x. And if the power is for the base, look at log x base a raised to n. Log x to the base a raised to n is 1 by n log x. Log x to the base a raised to n is 1 by n log x. This is the change of base rule. Log x base y is log x upon log y with any base. You can even ignore writing base. What you remember is log x to the base y is log x upon log y. Well, applying this, the previous questions of this kind, log 25 to the base 125 is log 25 upon log 125. You keep the base 5. Right? Log 64 to the base 16, keep the base 2. Log 64 to the base 2 upon log 16 to the base 2. So it is very important, this rule, change of base rule. Log x base y is log x upon log y. If you interchange y as a number, it is a reciprocal. Log x base y is 1 upon log y base x. And if that product, log x base y, the log y base x, 1. If you have many, log x base y and log y base z and log z base u is ultimately log x base u. When I don't write log in our topic, it is log x base e. Right? Log a base a is 1, log 1 base a is 0. Further, second order. Log and exponential are inverse of each other. We don't need to consider this inverse function. We don't need to worry about that. But log a raised to x to the base a is x. And a to the power log x base a is also x. Especially, this will apply many times in calculus also. E to the power log of x to the base e is fx. Remember, some topics they deleted, but that is actually it is just a haphazard deletion, because composition of functions deleted. But without composition of function, there is no mathematics for you. Remember. So you don't think that composition of function is deleted, so nothing regarding composition will come. If the composition of function is not there, what is there to learn in mathematics? So what they mean is that no question will come based on the composition function. That is what it means. Are you getting the point? Say composite function is deleted. What it means is, it is not that composite function cannot be studied, not necessarily need not be taught or need not be studied. Composite function is a vital point. Without that, how will you differentiate? Composite function rule is there. But the only thing is that there is no question regarding composite function, that's all, in the board exam. That doesn't mean composite function is not to be studied. In the same way, inverse function. Without inverse function, what is the meaning of inverse trigonometry function? So what it means is there is no question regarding the inverse function, that's all. That will not be asked as a question in board. All the deleted topics have that status. It is not removing the, they are not removing the syllabus. What they are deleting is that questions, that kind of questions will not be in the board paper, that's all. You cannot ignore inverse of a function. If you do not know inverse of a function, if I am not talking about the inverse and composition, then how you talk about inverse trigonometry function? How you talk about integration, differentiation, all are coming there. So what the board means, the board has clarified that. The question regarding that, the question regarding the properties of inverse trigonometric function will not come. Okay, a raised log x base a is x. We are running out of time. Can you answer these questions? We were about to discuss this last day. This we know, we have already discussed now. I have something more here. Can you tell me what is a raised to minus log x base a? This was actually a question discussed earlier with a different number. A raised to minus log x base a. Can any of you answer here? Should I give the answer? What we know from here is a raised to log x base a. When this base and this base are same, a raised to log x base a is x. Is x. A raised to log x base a is x. Here it is. This way and this base are same, but there is a minus. That minus should not be part of that formula. So what we do? Minus log x, we can write log x raised to minus 1. So this will be a to the power log x raised to minus 1 to the base a. And the answer is x raised to minus 1 or 1 by. Similarly, a raised to 2 log x. This 2 should not be part of the formula. So 2 will come here, it becomes x squared. The answer is x squared. Same thing can be done in question number 3. 16 raised to, but here the base is 2. So what we do here? We write 16 as 2 raised to 4. And then 4 will come here, 3 raised to 4. It will be 2 raised to log 3 raised to 4 to the base 2. That is, the answer is 3 raised to 4, that is 81. And this one, this base is 25, here base is 5. This 5 we can write 25 raised to half. When you write this 5 as 25 raised to half, 25 raised to half, we have discussed it earlier also. This is directly from that. 25 raised to half log 20 to the base 25. Then half log 20, we write log 20 raised to half. The answer is 20 raised to half. Same thing here, 9, you write 1 by 3. The base is here 1 by 3. 9, you write 3 raised to half or 1 by 3 raised to minus half. 1 by 3 raised to minus half. That minus half will go here at 5 raised to minus half. The answer will be 5 raised to minus. Can you make a fast recap of this question? If A1, A2, A3 are in GP, PQR are in AP, what is the value of log AP, P and 1, log AQ, Q and 1, log AR, R and 1? What is the value of this determinant? Well, if you want to prove, I can go fast. We are running just out of time. AP. In the progression, arithmetic progression, like the first term I denote capital A and common ratio capital R because small a and R are topic numbers given here. So what is AP? AP is A into R is to P minus 1 and AQ will be A into R is to Q minus 1 AR. What is log AP? While log AP is log A into R is to P minus 1, that is log A plus log R is to P minus 1, or that is P minus 1 log R. Log AP, log AQ and log AR. Substituting the value of log AP, log AQ and log AR. Log AP is log A plus P minus 1 log R. Log A plus P minus 1 log R. Then P1 log A plus. Now the value is obvious. C1 changes to C1 minus log A into C3. Log A cancels. First term will be simply P minus 1 log R. Take log R common out. P minus 1, Q minus 1, R minus 1. Add C3 to C1. C1 into C1 plus C3. That is PQ. Now it is 0 because first column and second column are identical. Well, we are running beyond time. These 3 questions you can take care of. I'll upload this for your reference. So we'll meet back Monday. All the best. Don't worry about duties. You'll do it well. Okay.